Good morning, my wonderful children. Those from Christabel International School. I'm Mr. Okachi Chukwemeka, your chief host for today's basic science class. And we're going to look at the topic called states of matter. The question is, what is the matter? Before I continue, I have my biscuit. I chew my biscuit. I take water to digest the biscuit. I breathe in air. I breathe out air. It means that the biscuit is the solid, the water is the liquid, while the air is the what? The gas. Take note of that. Now, what is matter? Matter is anything that has mass and occupies space. Take note that matter are made up of what? Of atoms. The question is, what is an atom? An atom is the smallest particle of what? Of an element. Take note of that. And I want to also know that your atom is subdivided into three particles, which are the proton, the neutron, and the electrons. Now, the proton are positively charged particles, neutron has no charge, and electron are negatively what? Charged particle. Now, the proton and the neutron makes up the center of an atom called what? Called nucleus. Take note of that. Now, what's an element? An element is a substance that cannot be splitted or broken down into into simpler form. Take note of that. And you see, in the periodic table, we have about 108 elements in in the periodic table, starting from hydrogen. Is that the key? Hydrogen, helium, lithium, beryllium, boron, and so on and so forth. All these are their elements. Now, let's now go back to the states of matter. We have basically four states of matter, which are the solid, the liquid, the gas, and the plasma. Now, before that, let me play an experiment for you to watch. Just listen to the experiment. Let's see this experiment. Let's watch this experiment.
Hi friends, do you know what I just did? I just took in the three states of matter: solid, liquid, and air, a gas. So are you ready to explore the three states of matter with me? And then we'll finish off with our top three questions on this topic. I'm sure you're familiar with the three states of matter: solid, liquid, and gas. When we look at something, our brain automatically knows, is it a solid, liquid, or a gas? In this video, we are going to compare these three states of matter in a more scientific way. So we'll compare them based on these four properties.
They are comparing them based on their on their shape and volume, compressibility, rigid or fluid, fill container completely. Is that the key? Now, let's continue. Now, we're going to be looking at matter based upon the arrangement, based upon energy of particles, also based on the distance between particles. Now, look at matter is made up of particles which are continually random motion. Look at this thing, it's moving, it's in a random motion. Take note of that. Now, I mentioned earlier on that we have four states of matter. First, I will take solid. When you see solid are what? They are closely They are closely packed. They are tightly packed. And take note, they have a fixed position, meaning they have a definite shape and a definite volume. Look at example of sugar now. Sugar is an example of Of solid. You see that it is difficult for you to compress your sugar, and your sugar has a definite shape and a definite volume. Now, look at it. This is a picture showing matter, element, compound, showing what? The particles around it. Okay? Now, we'll move into the next state of matter called liquid. Liquid are tightly packed. They are tightly packed. They have indefinite shape or the definite word volume. Why do I say they have indefinite shape? For example, now I have a container, a glass filled of water. I pour that glass filled of water into another container. Definitely the shape changes, but the volume still remains what? The same. Take note of that. I have a cup. I pour a glass cup of water into a cup. What happens? It has changed the shape, but the volume still remains what? The same. Is that the case? Now, gas. Now, the particles of gas are very what? Far apart and move freely. That is, they do not have a definite shape and a what? And a definite volume. Put that at the back of your mind. Now, what about plasma? Plasma is an ionized gas. But before I talk about plasma, let me
compare them at a particle level. Let's start with solids. Do solids have a fixed shape? Yes. As you can see here, they have a fixed shape. This is a cuboid. This is a cube. This is a sphere. And my watch has a irregular shape. So for solids, the shape does not change. Now, do solids have a fixed volume? Again, the answer is yes. Because the space that the solids occupy does not change.
Definitely.
The volume is fixed. And we can calculate that volume. For example, the volume of a cuboid is length into breadth into height. The volume of a cube is a cube. The volume of a sphere is 4 by 3 pi r cube.
Now let's continue from where we stop. I said plasma. A plasma is an ionized what? Gas. Take note of that. I want to also know a plasma is a very good conductor of electricity and is affected by magnetic field, meaning plasma contains ions. And ions are what? Negative or what? Or positive. Ion contains anion and what? And cation. Take note of that. A plasma is like gas that doesn't have a definite shape and a what? And a definite volume. And take note, look at this. Solid, liquid, and what? And gas. Now, what are the examples of plasma? Fire is a typical example of what? Of plasma. Flames, the example of what? Of plasma. Lightning, the examples of what? Plasma. Take note of that. Also, your sun is a typical example of what? Of plasma. Put it at the back of your mind. Now, let's look at the change in the phase or change in the state of matter. When liquid changes to solid, it is called freezing. But when solid changes to liquid, it is called what? Melting. Put it at the back of your mind. Is that the key? And also, when liquid changes to gas, it is called vaporization. When gas changes to liquid, it is called condensation. And when solid changes to gas, it is called what? Sublimation. But when gas changes back to solid, it is called deposition or what? Or desublimation. Look at this diagram. Your liquid here is changing to what? To gas. Evaporation or vaporization. But that gas changing back to liquid, condensation. Look at the solid is changing to what? To gas, sublimation. But what? Your gas back to solid, deposition. Take note of that. Look at this now. Your water is changing to solid, like freezing. But back solid to liquid is called what? Melting. Look at the diagram there. The same thing applies to this diagram. The same thing applies to this. Also, look at the arrow. The arrow is indicating what? The change of what? Of state. Put this at the back of the word, at the back of your mind. Now, before I round off my class, let me play you another brief clip on what? On the state of matter.
this one and this one. And you carefully take a look, what is the change in volume and shape of the liquid. So are you ready? Let's start. Now I'm going to transfer the water from this beaker into this bottle here.
Look at what is happening in that experiment. Pay attention.
And then I'll transfer it to the glass here.
Volume, but no definite shape. That's what is happening there.
Now let's transfer it to the...
It means that it has a definite volume, but no definite what? Shape.
Measuring cylinder. Have a fixed volume. It was 100 ml all the way through. But they don't have a fixed shape. As you saw in the experiment, the liquid takes the shape of the container it is put in. Let's talk about the compressibility of liquids. If you take a plastic bottle like this, flow easily. As you can see, water can flow easily. So liquids are fluids. Do liquids fill their container completely? The answer is no. As you can see, in the glass and the bottle, the water only occupies its own volume. The rest of the container is air. So liquids do not fill their container completely. Let's place the properties of liquids on our concept board. Now let's take a look at the third state of matter, gases. Gases have neither a fixed shape nor a fixed volume. Just like liquids, gases take the shape of the container that they are in. One difference is the container needs to be closed. Now liquids have a fixed volume, but gases don't even have a fixed volume. The volume of the gas is the volume of the container. So for example, if I transfer this gas into a larger container, it will fill that container completely. Or if we apply some pressure and try to fit it into a smaller container, then the volume of the gas will be the volume of the smaller container. That brings us to the next point, compressibility. Gases are highly compressible. For example, I can easily squeeze this balloon, or I can easily crush the air in this bottle. Gases are usually stored under high pressure since they are highly compressible. That way we can fit more of the gas in a small container. For example, compressed natural gas is stored in cylinders at a high pressure. Just like liquids, gases are also fluids. They can flow. For example, if I open this bottle, can you see the air flowing out? Of course you...
Now when we look at that experiment I was performed, you see that gas can occupy a content that is they are compressible. Now pay rapt attention to, based on what you have studied so far under the solid state of matter, under the states of matter, is there any question you'd like to ask me? Now, I really appreciate your effort for taking time